All right, example 2, 3/5 divided by 1/4. So I know that I have 3/5. What I need to know is how many fourths I have within that 3/5. So if I have 3/5, I need to model what? Crickets, crickets. 3/5. All right, well, I got like 2 people awake. That's good. Not. So someone from table 1, if I need to model fifths, how many pieces do I need? 5. Table 2, if I need to model 2/5 or 3/5, how many fifths do I need to shade in?
3.
Trace. Okay. So now everyone can agree that I have 3/5 modeled, right? The question is, I need to know how many fourths go into there. So if I'm adding and subtracting fractions, can I add and subtract fractions with different denominators?
No.
Can I really compare fractions with different denominators?
No.
Not really. It's kind of hard to do. So what do we do whenever we want to compare fractions to make sure that we know that all the pieces are the same size? We have to find a common what? Denominator. All right, so let's look at 5. Let's look at 4. Is there a common multiple between 5 and 4? 20. Okay, I know that I could rewrite this as how else can I think of 3/5? I know I need a denominator of 20. So what do I have to multiply by 5 to get to 20?
4.
So if I multiply the denominator by 4, I also have to multiply the numerator by 4. So what's 3 times 4?
4.
Okay, good. Now this 1/4, I can think of 1/4 is the same as how many 20ths? What do I have to multiply by 4 to get to 20?
5.
So what I'm basically doing there is finding the opposite of the simplest form. I'm finding a more complicated fraction, a fraction with more factors. But is it the same size? Is 12/20ths the same size as 3/5? Yes. Is 1/4 the same size as 5/20ths? Yes. It's still showing the same piece out of the whole. I'm not changing the size, I'm just changing the digits in my fraction. So if I have 1, 2, 3, 4, 5 pieces already, and I need 20ths, I need to show each piece as being 1/20th. How many times do I need to split each one of these fifths?
4.
4 times. Very good. So here I have 4, 8, 12, 16, 20 20ths. Can everyone agree that one of these pieces is 1 out of 20? And I know that I have 12 20ths. But the question is, how many 1/4ths do I have in the 3/5? Well, how many 20ths do I need to make 1/4?
5.
Why do you say 5? 1/4 is equal to 5 20ths.
Yeah.
So I need to count 5 20ths. 1, 2, 3, 4, 5. Everyone, what does this 5 20ths represent? Everyone, what does this 5 20ths represent? Okay, so that's 1/4 or 5 20ths. Do I still have more? Yeah, so I need to count 5 more. 1, 2, 3, 4, 5 20ths. What does this 5 20ths represent? And then I have 1 2/20ths. 2 out of the 5 that I need. So I've got 2/5. What was the question? It says 3/5 is how many 1/4? So if this 1/4, that's 1 1/4, 2 1/4. So I have 1, 2, and 2/5. So this 1/4 is the same thing as saying 1. This 1/4 is the same as saying 1 because I'm going in units of 1/4. So here's 1 plus 1 plus 2/5. What is 1 plus 1? What is 2 plus 2/5? What's another way I can think about this problem? I could have rewritten this as 12/20ths divided by 5/20ths. What do I notice about 12/20ths and 5/20ths? What's the same about them? Anytime you have the same denominator, what can you do? Yeah, ignore it, because remember I did that whole annoying, what's 8 divided by 2? 4. What's 800 divided by 200? 4. What's 8 ninths divided by 2 ninths? 4. So I know that if the bottom is the same, just ignore it. So then how many times will 5 go into 12? 2 times, with how many left over? 2 and 2/5. All right, so I know that you guys don't like the models, but we have to somehow relate them to this because that's part of the standard, okay? Let's do the easy thing. Let's go back to say, all right, well, here's my 3/5 divided by 1/4. What's my saying? What's my shortcut? Keep, change, flip. So what am I keeping? Go ahead, Jose. Three-fifths times what? 4/1. And then 3 times 4 is? 5 times 1 is? And this should look familiar. So how many times will 5 go into 12? 2 with how many left over? Good. So what do we learn about this, guys? No one learned anything? I need to spend the next hour and 45 minutes or hour and 50 minutes talking about it? All right, well, give me something. What did we pick up? Key, change, flip? That'll get you that answer. Okay. Simplify. If we have something to model, we model it, and then we cut it up into pieces. What if I have different denominators? What do I have to do when I'm modeling? Find a common denominator. Very good. Another way of thinking about that is finding a common multiple. If I count by 5s, I can go 5, 10, 15, 20. If I can count by 4s, I can go 4, 8, 12, 16, 20. 20 is my first common multiple. So that allows me to compare different fractions, different size fractions, with the same size units. I ended up with 12/20ths divided by 5/20ths. I saw that I have like denominators. What can I do when I have like denominators? Yeah, anytime you see like denominators, do yourself a favor. Ignore them, cross them out, and go on.